Hello guys, welcome to my YouTube channel. Today we're going to be looking at measurement of structural steelworks. So let's dive right in. And from the drawing we can see, so this is for a column alongside some beams attached to it. This is universal beam 254 by 102. And the second beam attached to this part is universal beam 305 by 165. And this is the plan of what we're going to be using today. So this is the plan, and this is where we got the section from which we got this image. This is where we sectioned out. Yes. So also among the things we're going to be measuring today, we're going to be looking at a built-up girder, which is this from this point here. So all the way from here to here, it's a built-up girder, meaning it's a beam that was built up on site, whereas other beams and columns were prefabricated. They were both already coupled together. This is the taking-off list we are going to be using. So I'm going to be considering the columns. So in our drawing, we have about 11 columns. In our plan, we have 11 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 columns. Yes, so we're going to be considering its fittings, such as the base plates and the gusset plates and the angle cleats and the holding down bolts. And so the base plate is attached to, as the name implies, to the base of a column. Yes, before it's attached on the grout. Yes, for more stability. The gusset plate is attached to the sides of a column. The angle cleat is also attached to the sides and down to the base plate, which provides support to the joints. Yes. Also, the holding down bolt, which comes from the concrete work underneath and through the grout. It passes through the base plate, then through the angle cleats, which is now bolted down together. Then also to the beam, we're looking at allows for fittings, its top angle cleats and bottom angle cleats. Yes. So for a beam, its angle cleats are going to be on both sides. Yes, on both sides to reinforce it in a, of course, the beam is going to be attached to columns. So it's going to need angle cleats, one at the top, one at the bottom, to keep it reinforced, something like this. So it's an angle cleat here, an angle cleat here. So similar thing will be done on the other side to keep it sturdy. Okay, also we're going to be looking at built-up girders in our construction today, measurement today. Yes, so this is the built-up girder. And spoke about flange, the web, the stiffness, allowance for fittings, the top angle cleat. So everything is going to be fabricated on site. So you have to piece out everything together. So this middle section is the web. This section here is the stiffness. The stiffness supports the flanges on opposite ends. So this plate here is called the flange. The one at the bottom is also known as the flange. So 1, 2 is known as the flange. They are flanges. Then the one at the middle is the web. This one by the sides at specific interval is known as the stiffness. And this is the angle cleat that gives support to the beam. Okay, now so we're going to be starting with the calculation for our column. So the first thing for us to go get is the height of the column, because from the drawing here we're given the height of the entire structure, vertical structure, which is from here down to this point. But knowing fully well that the grout is not part of the column, this base plate is not part of the column. It's attached to it, but um, it's not parts. These are parts that you fabricate on sites. Yes, that will mean that we have to less the grout. We have to less the base plate for us to get the actual length of the column. Okay, so we have our height as 9 meter. So we're going to less the grout and the base plate, and we'll have our answer as 8.955.
All right, so we broke for the heights of above for um the column heights. Yes, so there are 11 columns in total in the structure. So we'll multiply that by 8.96 to get a value, and we'll get our value shortly. Um, that's 8.96 times, right? So that's it there. Okay, at this point, of course, all the descriptions, it's not something you necessarily memorize. They are in the BSMN. Ah, yes, also, if you can see, we're going to be multiplying the value we got by 107 kg per meter, and also dividing the answer by 1000 will give us our value in ton. Because you're going to buy the metal in tonnage, not in meter. So it's going to be sold in tonnage. So that is the method. Multiply the length by the weight per meter, then dividing it by 1000 will give us the length in ton. And of course, that's the market's standard.
Okay, so moving on, we're going to be looking at allowance for fitting for our column. So starting off with the base plate, and from the drawing now, you can see its length and breadth given us. So 495 by 580, and it's 15 mm thick, and it has a weight of 7 kg per meter. Okay, so we're going to allowance and fittings. So starting off with the base plate, allowance and fittings, allowance for fittings, and allowance for fittings. Okay, so starting off with the base plates, um, so we just describe it's a 15 mm base plate, and you also indicate its weight, kg per meter square. So by doing this, you get a value in ton. Okay, and in the BSMM, it's in found in section 1.15 by 1. So it's always important for us to add the section, especially in academics, of course, um, because it attracts mark as well. Yes, towards the booking. So the length and width of our gusset plate. Length and width of our gusset plate is 495. So we're going to approximate that is going to be 500 mm. So 0.50 by 0.58. And of course, it's occurring 11 times. That's for 11 columns. Each of them are going to have a base plate. So that will be 3.19 when you multiply it by 11. Okay, so we'll move now to the gusset plate. So from our drawing, the gusset plate is its descriptions. So gusset plate 580 by 300, 12 mm thick, 5 kg per meter square. Okay, so Um, let's book that before we describe. So 0.58 by 0.30. So it's going to be on both sides of the column. So multiplied by 2. And of course, it's going to be on 11 columns. So by 11, we'll have our value as 3.83 when we multiply that. So you can do that yourself to confirm. Um, so in describing it, 12 thick corset plate. So its weight is 5 kg per meter square. So of course, these are two values. So that's why it's in meter square. Um, yeah, so kg 1000. So I get your value in tonnage. And you also add where you got the description from in your BSMN. Like I said, it's attract additional mark. All right, so moving on to the angle cleats. So far, the structures we've been looking at, which is the base plates, the fittings rather, we've been looking at base plate and gusset plate, happen to be in either a square or rectangle, like a plain figure. Okay, but angle cleats now, it's kind of different. If you see it, it has like an L shape. It's not like a square. So that will imply that we will not be measuring it in square meter. And because from here to here, that's just one face. So how long or how wide is going to be to determine on the side of the structure is attached to. So in this case, is the side of the column. So that side of the column is 254, because from our drawing we see it's 254 by 254. So it's going to take the length of the structure is attached to. For more clarity, when you're also considering your beam now, when you want to look at the angle cleats for your beam, so you take the width of the part is attached to. So in this case now, um, the angle cleats now we take the width of this particular beam as from here to here, meaning your 102 by 102, for instance, is 102 by 102. So the length from here to here is going to be what this place is. Hope we understand that. Okay, so let's continue. Our angle cleats from our description here, we can see it as 102 by 102 by 11 mm. So multiply by 2 kg per meter, because it's going to be in linear meter now, not um, square meter. Once we've done that, so for the sake of time, I won't be writing the kg per thousand per ton. So you should have gotten that by now. So 1.5, 0.5, 0.1, so all of them are in the same section. So meaning we're going to be taking 0.25, which is for this we're taking one side, the side of the width of the column. So by we're going to have angle cleats on both sides, so by 2, and on 11 columns, of course. Okay, so the next item we're going to be looking at from our taking off is a holding down boat. Holding down boat. So for the holding down boat, it's measured in items. It's measured in items. That will mean we're just going to take numbers from the description we've been given. It said four, that's four numbers, or which is 25 in diameter, 450 holding down boats with 100 by 100 by 11 thick plate washer welded. So that's it. You just simply um, describe that, and addition to what we see in our BSMM. So that will be four number because you're going to have it on four sides, right? One, two, then one, two again. Just four sides. Don't have it in my drawing, but it's going to be on four sides for stability. And it's going to be on 11 columns. Then 44. So holding down both assemblies MS 25 with nuts and washer. And just to add, your description mustn't be exact with what you were given in class or what I'm doing. It's basically for you to have the understanding. And when you go through your BSMM, you will see basically um, almost everything you can write. And just having that understanding rather than trying to cram, that will not be advisable. I won't advise you to cram descriptions. Just understand it. It's if you have the understanding, it's very easy to write. So this is where it's found in BSMM. Now we'll move on to, so we are done with our column. So we'll move down to a beam now. Okay, looking at the drawing now, we have two types of beam. This beam 305 by 165. And we also have another beam which is 254 by 102. So these are two different lengths of beams at different sites. So that will mean that we will have to treat the beams separately. And also, if you can see, as you can see, the arrangement of the columns for this part is having like an I shape here, I shape, I shape. It's a H beam anyway. It's having like an I shape, I shape, I shape, I shape, I shape. But when it comes here, it's like looking like a H, looking like a H. So it actually has significance. So it's going to affect the way we measure, right? And you can see the length from here to here 6 meters, 6 meters, 6 meter, 4 meter, 4 meter. Okay, so let's start with the beam A. We'll see the significance of these positions and how they affect how we measure along the line. So let's first of all identify beam 305 that we have on this plan. So we have 1, 2, 3, 4, 5, 6, 7. So among beam 305s, let's identify the beams that have similar column arrangement both at the left and the right. So this have the same column arrangement. But when it comes to this one, they have like an I shape here, they have the H shape here. So this is different. So we have 6, 1, 2, 3, 4, 5, 6, 305 by 165 beam that are similar, and we have an outlier, which is this one. So let's book for it. Okay. Now for us to get the length of beam 305 by 165, now it will mean that we have to deduct something from here and here. So in this case now, we in our construction, we are assuming the thickness of the column as 6 mm, the of the H column as 6 mm. So it will mean we'll deduct 6 mm from this part to this part for us to get actual length of the beam, because from our drawing we are given from this point is the outer side to this outer side here as 6 meter. So it will mean that we have to deduct the thickness of both sides of the column to get the actual length of the beam. So that's why I said the shape of the column will have implications. So it will mean that 305 of this configuration I on both sides will be different or longer than the beam that is having I and H configuration of its own column. So this will be shorter than this. Obviously from here to here is shorter than from here to here. So that's what we are saying. So taking the thickness of the beam as 6 mm, then we'll get to deduct as we go. Okay, so like we earlier established, we have six numbers of 305 that's having this setting or configuration of its columns. So it's going to be 6 meter. You less 2 by your 6 mm. So converting it to meter is going to be 0.006. So 2 times that 0.006, we're going to have 0.012 is what we have here. And by the time you less it from your 6 meter, we're going to be having 5.988 as an answer. So we'll also do the same thing to the B, the outlier, the other beam, which is this one right here, where our section was gotten from. So it's 1 plus 1 in number. So 6.000. You less, so we less the web, which is the thickness, we're assuming as 0.06. So we'll less that. And also, that's not just what we'll be lessing this part as well. So knowing fully well that the H beam is 254 by 254, meaning that if we are taking half, because from here to here is half of the column, so we'll be taking the half length of the column, adding it to this part here, and deducting it from 6.